subscribe.
Hey y'all, welcome back. So last time we reviewed linear functions, and today we're going to review quadratic functions. So just to kind of go back over the different forms that these functions can take, the first one here is going to be vertex form, which is f of x equals a times x minus h squared plus k. In this case, h and k are going to be where our vertex is. Okay, so I'm going to make a little note here that our h and k, so h comma k is actually represents the coordinates of the vertex. And as we go through some of the problems, I'll do a little bit more explanation to what that means. But basically, that's the point on the parabola where the slope changes from negative to positive. It represents either the relative maximum or relative minimum, depending on how the parabola is oriented. So HK is the vertex of the graph. And we'll also get into like how, what does A do on the graph when we come back to that. So like I said, we'll come back to that. Standard form here is going to be f of x equals a, and this is actually the same value as the a above. Okay, it's the coefficient, it's the leading coefficient. Ax squared plus bx plus c. And just like with the standard form for linear equations, the a and the b here are not going to be like directly represented like as a point or anything on the graph, but c is going to be the y-intercept. So I'm going to make a little quick point about that. And the last form here is going to be this factored, or sometimes it's called the intercept form. And this is where, and this really only works for quadratics that are factorable, but if you can factor them, then they're going to be in this form. Either a times, and this is the same a in all these, okay, it's the leading coefficient, times x minus h, or I guess I've already used h, so I'll say p times x minus q, where p and q are the x-intercepts. Okay, so p and q are the x-intercepts. So let's go through each of these problems and see, and we'll come back and talk about A as we go through it. But let's take a look here at number one. So for this one, we're trying to figure out what the equation is. So there's a couple things we want to look at here. First of all, if we look at the vertex, which is this point right here, we can see that it's 2 comma negative 1. So that means that our HK is 2, negative 1. And if we think about how these equations are written in vertex form, the h being 2, we would be looking for an x minus 2. And then the k being negative 1, we would be looking for a plus negative 1 or just minus 1. So, so it looks like the combination that we need here is going to be, let's see, minus 2, minus 1, which is going to be right here. So the only option at this point would be choice C. Oh. Wait a minute. What happened to, I deleted my little thing there. Okay, well, let me put that back in there. HK is the 2 comma negative 1. Now, one of the other things that I want to just bring up here that's going to come back later is looking at these a values. Notice how some are positive and some are negative. If the parabola opens down like this, then you can expect a negative a value. If it opens up, you can expect a positive a value. Now, as far as how the a value affects the graph, we didn't really need to know that to answer this multiple choice question. We know it's going to be C. But the 1/2 here, or negative 1/2, is really describing the change for 1 unit. So it's describing the change in y if you move 1 unit away from the vertex. So what I mean by that is, like, if I go to the right 1 unit here, so like starting from the vertex, if I go to the right 1, the question is like, well, where's my function from there? And what I have to do to get to this point right here is I go down 1/2, or like negative 1/2, and that's how we're going to figure out like what that a value is. So you start at the vertex, you go 1 over, and then however much you go up or down, that's going to be your a value. So yeah, let's take a look at the next question, another multiple choice item here. A quadratic function is in the form ax squared plus bx plus c. So just as a reminder, this is called standard form. And this is just a very general question about how a affects the graph. And we just really discussed that. So if a is positive, it's going to open up. And if a is negative, it's going to open down. So it's asking for us to describe that. So if a is positive, then the parabola opens upward. Okay? In other words, like we've got, sort of like a smiley face parabola. Okay? And if a is negative, then the parabola will open down. Can I spell here? Parabola opens down. Wow. Open up. Nice grammar there. Okay, yeah, so the parabola opens up, the parabola opens down. And then it starts asking about the c values. Okay, so the c values, recall, is the y-intercept. So if that is positive, then we'll say that we have a positive y-intercept. So the y-intercept is positive, meaning it'll intersect the y-axis above the x-axis. Now, if c is negative, then we can say that the y-intercept is negative. Yeah, so that's going to be the descriptions for what would happen in these different scenarios. Number 3 says, what are the x-intercepts of this function? So this is, so we need like a little y here, a little typo here. There should be a y in here. Or at least an f of x works too. But either way, this equation looks like it's written in this factored or intercept form. And so whatever p and q are going to be our x-intercepts. So one way to think about that is like if you were to set these equal to 0 and solve for x, like if I said this one equal to 0 and I said this factor equal to 0, then I'm going to get x equals -4 and x equals +6. And so the coordinates of these x-intercepts are going to be -4, 0 and 6, 0. So those would be the coordinates of the x-intercepts. So if it's really nice if your function is in factored form because you can get the x-intercepts really easily. So yeah, let's go on to number 4 here. On number 4, it's asking us to match up the equation to the graph. So if we factor this and put it into that intercept form, kind of like the last one, what we would get is x plus 3 times x minus 1. And we can see that our x-intercepts are going to be -3 and +1. So if we're looking at those, we can eliminate some of these options. So like this a has its x-intercepts at -3 and 1. So that might be the answer. This one has -1 and 3, so this one definitely cannot be the answer. -1 and 3 again, and then D has them at, what was that, -3 and 1. So it's either A or it's D here. And so what we want to do is look at the A value here. So the A value here is just 1. When you don't see a coefficient up here, it's just a 1. And so we want to look for the graph where if you go over 1, you go up 1. It's a little hard to tell here. If I zoom in, maybe we can see it a little easier. We can see like on this one, I do go over 1, up 1. So this is going to be our answer A. But if we compare that to choice D, if I go over 1, I'm going up 2. So this would be like if the A value was a 2. So you see how we're going up 2 there versus going up just 1 on this one. So we can determine that, in fact, the answer here is A. All right, so let me erase this little question mark now that we've actually answered the question. Good, so let's look at number 5. We want to analyze and graph this. So the first thing I want to do is see, can we factor this? So let's go through the process of factoring. When the A value is 1, it's a little bit easier. When the A value is not 1, it's a little trickier. It may not even be able to be factored, but let's see if it can be. Not 100% sure on that. So what we would need to do to factor this is we need to find two values that multiply to give me the product of the leading coefficient and the constant, meaning we're trying to find two numbers that when you multiply them, you get positive 10. Okay, so that's negative 5 times negative 2. And those same two numbers have got to add to give you 8. Okay? And the reason we're doing this is because this is going to be how we factor these by grouping, is we are going to break down this middle term into a sum of two terms that satisfy these conditions. So let's see, two numbers that multiply to give me 10, add up to 8, are, let's see, 5 and 2 won't work. Those are our only factors here. So yeah, this one's not going to be factorable, unfortunately. So what we're going to have to do is to get the vertexes, we're going to have to rewrite this in vertex form. Okay, so to do that, we're going to use a technique called completing the square. To complete the square, what we're going to do is we're first going to factor out that negative 2 out of those first two terms. So that'll give me x squared plus minus 4x. And then I'm going to leave a little bit of space here. Okay, I'm going to come back in here. And then I have the minus 5 just kind of hanging out. So what I need to do is find a number that if I add it right here, it'll make what's inside these parentheses a perfect square, so that I could rewrite it as like x minus something squared. And so that number is always going to be this coefficient right here divided by 2 and then squared. So if I divide negative 4 by 2, I get negative 2, and if I square that, I get 4. Now I can't just arbitrarily add 4, okay? That's going to change what the graph looks like. So what I need to do is subtract the same amount so that it sort of evens out, right? Like I'm allowed to add 0, but here I need to subtract away the same amount that I'm adding. But so we want to be careful though, because I'm not actually adding 4 here since we've got this negative 2 hanging out. What I'm really adding is a negative 8. So to balance that out, I actually need to add 8. Okay, so if I add 8 and subtract 8, all is still well, all is good in the world. We'll still have the exact same equation. So anyway, we got to add 8 to balance out this minus 8 that we just sort of threw in there. Now, the whole reason we threw that in there is if we factor that trinomial that is inside the parentheses now, we're going to get x minus 2 squared. And you can see we're slowly getting this into vertex form. Negative 5 plus 8 is going to be plus 3. And this whole technique, by the way, if you want to Google it to get more information about how it works and see more examples, it's called completing the square. Okay, so now I can write the vertex here. It's going to be 2, 3, okay, because x minus h, and then plus k. So 2, 3 is the vertex, and we can plot that over here. So 2, 3 goes here. Well, let me try to make a nicer dot than that. 2, 3 goes here. Okay, now my a value here is negative 2. So what I'm going to do is I'm going to go over 1 and I'm going to go down 2 to get the next point. Okay, so over 1, down 2. And to get the next point, I need to go over 2 and then down. So the way this works is normally you go over 1 and then down 1 squared, right, which is 1. Now, if you've got this coefficient, you're going to multiply how much you're going down by that number. So if I go over 2, and normally I would go down 2 squared, which is 4, Okay, 4 times 2 is 8. So I actually want to go down 8. So over 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. Puts the next point right there. And we'll have the other point over here. And so now we've got enough of the graph to be able to start answering the questions here. So I'm going to draw this little parabola out. Here we go, all the way down. It's going to cross that y-axis. I'm going to try to make this a smooth curve the best I can with this mouse. It's going to be a lot easier to do this by hand. So there's the left-hand side of the parabola. Here's the right-hand side. There we go. Okay, so is this vertex, which the vertex we already established was 2, 3, a maximum or minimum? Well, since this is the highest point on the graph, we're going to call this a maximum. What is the axis of symmetry? So an axis of symmetry is going to be that vertical line which goes right down the middle of the graph. So in other words, it's going to be x equals whatever the x value of the vertex is. It's this line right here. So we're going to say that it's x equals 2. The y-intercept is, we can see, it's -5. We could have got that from the beginning, right? We see right here that the y-intercept is -5, but we can also see it visually on the graph as well. So it's going to be 0, comma, -5. The domain here is going to be all real numbers. So there's two ways we can write that. We can just say all real numbers. Let me type that out. Or if you, at this point, you're probably, starting to get used to set notation. So you could just say, as just like an alternate way of writing this, you can say parentheses, -infinity to infinity. So -infinity, comma, infinity. And so that would be the domain. And then the last question here is about the range. So these are all the possible y values. So it'd be all the values equal to or less than 3. And so two ways you could write that. If you write it as an inequality, you would just say y is less than or equal to 3. Or if you want to write it using set notation, you would say -infinity up to 3. And you'd put a bracket on 3 to indicate that you're including that in the set. There we go. So both of these two things mean the same thing. It's just a matter of what your preference is. I don't really care which way you write it unless it, it asks something specifically. Okay, so that's the end of that one. Let's take a look at number 6. So number 6, we're trying to find the vertex, the x-intercepts, and the y-intercept. So the vertex here is probably going to be the easiest thing to find. It's just right here. Here's our h and k. So my vertex is going to be -14, comma 7. All right, now as far as my x-intercepts, what I'll have to do is multiply this out and then hopefully be able to factor it. I guess we'll see if that plays out nicely. And same thing with the y-intercept. I'm going to actually have to multiply this out, so let's go ahead and do that. So we've got y equals -1/5, I'll just do that first, times x squared plus 28x plus whatever 14 squared is. So let me think about that. 14 times 10 would be 140 plus 16 to be 156. No. I got that wrong. 196. What it should be. So yeah, 196. And then plus 7. Okay, this is going to be nasty. Ugh, I don't like this at all. Okay, so, well, let's see where this goes. So if we want to clean that up a little bit, we get y equals -1/5 x squared. Plus 28/5 x plus 196 over 5, and I take that back, these should be minus. And then I still have that plus 7 hanging out there. So I want to combine these two like terms. So 7, if I need fifths, would be 7 times 5 is 35, so 35 over 5. And so now I've got this lovely equation. Oh gosh. So the difference between 196 and 35 would be 161, I believe. This might be a good, there's a good case here where you might just want to use a calculator, but I think that's right. I mean, I think this will work out pretty good. So we got, 190, the difference should be 161. So yeah, so what we've got here is negative 161 over 5. So this is going to be our function in standard form. I hope you like that one. So our y-intercept we can write down now is going to be negative 161 over 5. I'm sorry, 0, comma. And then I think I'll maybe type that out just to make it look a little nicer. Use this little math type here to this negative 161 over 5. Gonna have to bring that that second parenthesis out a little bit further. There we go. Okay, so that is our y-intercept, and so now we get to find the x-intercept. So to find the x-intercept, we need to set this equal to 0 and then solve it. So the same way we found the x-intercepts for linear equations, actually. It'll use different techniques, but the strategy of setting the other variable equal to 0 and solving, that's going to be the same. Yeah. So we need to, let's see if I can get this to come up. There we go. Okay, so I'm going to set this equal to 0. Right, and I'm going to solve it. Now the first step I'm going to do to really clean things up here is I'm going to just multiply everything by negative 5. Right, and so that's going to really, this is going to be positive 1. This is going to be positive 28. You can see it cleans up real nicely here. And then we got a positive 161. Now, does this factor? 161, I don't, gosh, when you can't figure out the factors quickly, then I think it's best that we just kind of go back to our good friend, the quadratic formula. And at this point, I think that's going to be the way to go here. I'm going to move these over just so I have a little bit more room here. So let's type out the quadratic formula. This will be a good opportunity to bring that up. And what the quadratic formula is used for is for finding the roots or the zeros or the x-intercepts of a quadratic function when you can't factor it or can't factor it easily. So here's what the quadratic formula is. It is x equals negative b plus or minus, because typically we do get two solutions here, the square root of b squared minus 4ac, all divided by 2a. Okay, so if I want to find the zeros of this, I'm going to plug in 1 for a, 28 for b, 161 for c. So yeah, let's start plugging all that stuff in. I'm just going to highlight and copy this. Probably the easiest way to go here. So we get negative 28 plus or minus 28 squared. Okay, so now I'm thinking, you know, I've gone pretty far without using a calculator here, but I'm gonna tap out at this point. I'm gonna use a calculator to simplify this. 2 times 1 is just gonna be 2. So so let's go ahead and let's move these out of the way so we get just a tad bit more room here. Actually, you know what I'll do? I'm going to move these all the way to the side. And then I'm going to put this right here. Okay, give myself a lot more room to work. All right, so I've got this nice, lovely equation. So yeah, I'm gonna bust out the old calculator at this point. I think it's kind of too much of an ask here to have you do that by hand. So yeah, what I'm gonna type in here is 28 squared minus 4 times 161. Should get a positive number here if there are any real solutions. So we get 140. Okay, now that is not a That's not a perfect square, so what I'm going to do is I'm just going to leave it there. Those are my x-intercepts. If you want to type that into the calculator, you can. You know, it's not really necessary, but you should get, if you do that, let me go ahead and type that in. What I'm getting here is x equals negative 8.084, or I'll just do a comma here. The other one should be negative 19 let me see what I got over here, 916. So yeah, there's two of them. Those are going to be your two x-intercepts. Not very kind x-intercepts. In fact, I kind of, they're irrational, so I kind of like putting these instead. But if like you needed to graph it or estimate like where it was on the graph, you would want the decimal. So my x-intercepts are going to be, let's just go ahead and write it like this, comma, 0. All right, yeah. So there you go. We found the vertex, the x-intercept, and the y-intercept. This is a nasty function. Gosh. We've had a couple of tough ones in a row here. Yeah, so let's keep going on, though. We'll look at number 7. Number 7 here says write an equation in intercept form that has the given x-intercepts and passes through 1, 18. So intercept form is going to take the form y equals a times x minus p times x minus q, where p and q are the x-intercepts here. So since they tell us the x-intercepts are -2 and 3, I can plug in -2 and 3 here. And the only thing I want to make sure to do is not leave it as minus and negative. It's not really how we want this to look. Anytime you have minus and negative, we're just going to change that to plus. And so the trick here is figuring out what a is. Okay, because they don't tell you explicitly, but they do tell you that it passes through 1, 18. So what you can do is you can plug in 1 and 18 into x and y respectively. So y being 18 and a being our lonely variable here, x being 1, and then we'll solve this for a, and then we'll be able to write our equation. So 1 plus 2 is going to be 3. And 1 minus 3 is -2. So we end up with this little equation, 18 equals -6 times a. And so if we divide both sides by -6, we're going to get a equals -3. So that's going to be our a value, and so now we can write our complete equation here. Y equals -3 times x plus 2 times x minus 3. And now we've got it in intercept form. Whoa, going for a box here, and it gave me a big old football. All right, here we go. Oh, nope. There we go. All right, so there's number 7. Number 8 says write the equation in vertex form. Okay, so recall that vertex form is going to be this f of x or y. It doesn't really matter which one you're using right now. Equals a times x minus h squared plus k, where hk are the coordinates of the vertex. So in this case, the vertex is 2, 1. So I'm going to replace the h with 2 and the k with 1. And then to find the a value, recall that we get that by going over 1 and then figuring out how do I get to the graph. In this case, I would go up 3, right? So plus 3. That means 1, 2, 3, yep, so that my a value should be 3. And that's the function in vertex form. You can also try to write it in intercept form. And so in this case, remember that intercept form is going to be a times x minus p times x minus q, where p and q are x-intercepts, and a is the value we need to go up or down after we move to the right 1 unit. So p and q are going to be 1 and -1. So it doesn't really matter which one's which. We're just going to put 1 in one of them and -1 in the other. So this is going to be x minus 1 times x plus 1. And to find the a value, if we go over 1, geez, really struggling with these arrows here. So So go over 1, we can see that we're going down 2 here. So our a value here would be -2. So there would be our equation for number 9. All right, well, moving on to the last page here, number 10. We want to solve this using the quadratic formula. So now we're getting into solving. There's a couple of different techniques you can use to solving, but primarily I'm going to focus on 2. Really, I want you to try to solve by factoring if you can, but as we've seen already, there are some cases where you just have to use the quadratic formula here, and I'm just going to copy it over once again because we have a little space for it. We did write it over here. And so I'm just going to copy it down so we don't have to rewrite it here. Oh, okay. Let's try that again. Come on, there we go. All right, so here is our quadratic formula, and we can use this to solve this equation, just like how we used it to find the x-intercepts in that other problem. Let's go ahead and start plugging in everything in. So we've got, let's see, negative b would be -4, which will be +4, plus or minus the square root of -4 squared. Make sure when you square that, you're going to get it +16. -4 times 3 times -6. Okay, all over 2 times a, which is 3. So I'm just using these values up here, right? Here's my a, my b, and my c. And now I'm going to simplify this. Let's see how far we can get without a calculator. So we got 4 squared is 16. 4 times 3 is 12. And 12 times 6, ooh, what would that be? 72. So plus 72. Let me double check that, but I'm pretty sure that's right. Let's see here. 4 times 3 times 6, yeah, 72. Again, 2 times 3 is going to be 6. We can simplify this a little bit more. If we add 16 plus 72, we're going to get 88. And since that's not a perfect square, we could just leave our solutions just like that. So we get 2 solutions: 4 plus root 88 divided by 6, and 4 minus root 88 divided by 6. Now this is like a multiple choice item. You might see this square root simplified out, and so I'm okay with you leaving your answer like this personally. But if you get, if you get a multiple choice item and this is simplified, what we can do is we can divide out a 4 out of this and get 2. So if I divide a 4 out, that would make this 22, so root 22. And then we can simplify all these by dividing by 2. So then we would get 4 divided by 2 is 2, 2 divided by 2 is 1, 6 divided by 2 is 3, and there you go. So this would be the simplified version of that. But this answer over here is okay too. Number 11, find the x-intercepts, and we've just got a few of these by factoring. So for these, we're going to factor, and so they shouldn't be too bad. We're looking for 2 numbers that multiply to give me 24, but add up to -14. So what is that going to be? I guess we've got 6 and 4. No, that's not going to work. 8 and 3. It's going to be 12 and 2. So x minus 12 and x minus 2 are going to be my 2 factors. So my x-intercepts are going to be positive 12, comma 0, and 2, comma 0. And basically the way that I'm getting those is I'm setting each factor equal to 0 and solving them individually. So like it's like if I say, okay, well, if I'm finding the x-intercepts, I need to set y equal to 0, and then I can use the 0 product property to say, okay, well, either x minus 12 has got to be 0, or x minus 2 has got to be 0. So that's where these two are coming from. To get to factor part B, we're looking for 2 numbers that multiply to give me 24 again, but add up to positive 11. So actually, this is going to be very similar to the last one, except our factors, I guess, would be different. So this is going to factor to be x plus 8 times x plus 3. All right, so my 2 x-intercepts here are going to be -8 and -3. And finally, if I factor this one, I'm going to, okay, so this is one where we're going to have to factor by grouping. So what we need are two numbers that multiply to give me 16. If this is factorable, I hope it is, and that add up to 10. So the 16, by the way, is coming from 2 times 8. So you multiply the constant and the leading coefficient. All right, so I guess that'd be 8 and 2, right? So this would be 8 and 2. 8 times 2 is 16. 8 plus 2 is 10. And so we can rewrite this as 2x squared plus 8x plus 2x plus 8. A lot of 2's and 8's in this one. Okay, so basically what we've done is we've split up this middle term, and this is just what you have to do to factor by grouping here. And so the next step is going to be to group the first two terms and the last two terms. So we're going to basically group up these two and just factor out the GCF out of each one. Okay, so the GCF out of that first group is going to be 2x. So if I divide out a 2x out of that, I'm just going to be left with x plus 4. And I can factor out a 2 out of this other one, so I get x plus 4. So my two factors here are going to be x plus 4 and 2x plus 2. So if I set each one of those equal to 0 and solve it, I'm going to get my two x-intercepts, which are going to be at -4. And let's see, -2 divided by 2 would be -1, so -1, 0. And that's it. So I know we covered a lot today. You know, we're going over pretty much everything that involves quadratics. So, if I went too fast, you might want to go back and kind of like watch individual problems again if you got lost, because I know there's a lot of algebraic skills that we're going over here. But, always reach out if you do have any questions, and I'll try to help you out individually. But other than that, y'all have a great day, and I'll see you next time.